Welcome back to the deep dive. Today we're diving into a pretty heavy topic, a tragic event in Texas.
Yeah, tough one.
The blowout of the Daniel H. Wendland 1H oil well.
And we're going deep into the official investigation report here.
Lots of technical jargon to unpack for sure.
Trying to make sense of it all for you. So it's one thing to read about an oil well disaster,
Yeah.
but to actually understand how something like this happens, especially in an industry with so much at stake.
Absolutely. And this report really dives deep.
Yeah.
So we'll try to break it down. So
Yeah.
let's start with the basics.
Okay.
The Wendland well, kind of your typical oil well, pumping away since 1980.
Rural Texas.
Yeah. Operated by Chesapeake Operating, L.L.C.
And, you've probably driven by dozens of wells just like it, especially here in Texas, and I think that's what's important to keep in mind.
Yeah.
How many similar wells are out there, each with their own, potential risks?
And this is where it gets heartbreaking. January 29, 2020.
Yeah.
A seemingly routine repair turns deadly.
Yeah.
3 contract workers lost their lives. Another critically injured.
Doing something called a workover.
Okay.
Kind of like taking your car in for maintenance.
Right.
Just trying to make sure the oil flowed smoothly. And here's the thing. This wasn't a new drilling operation. This well had been producing for decades.
Okay, so we're talking about a well past its prime potentially, with some wear and tear, undergoing a routine procedure.
Right.
What could go so wrong that it costs lives?
Yeah, and that's where all the details of this report really become crucial,
Yeah.
to understand what went wrong, and that's what we're going to unpack together.
So we've got this decades-old, well, a seemingly routine repair, and then tragedy strikes.
Mm-hmm.
What does the report tell us about, what led up to the blowout itself?
Yeah, so this is where the technical details get really important. The Wendland, was tapping into what's called an underpressured reservoir,
Okay.
meaning the pressure underground was lower than you'd typically expect at that depth. And you might think less pressure, less risk of a blowout,
Right.
but it's actually the opposite.
Okay, that seems counterintuitive. Why is that?
Yeah, so imagine like a bottle of soda with a straw in it, right?
Okay.
The pressure inside the bottle wants to push the soda up the straw.
Right.
To keep the soda from erupting, fizzing over, the pressure inside the straw needs to be higher than the pressure in the bottle.
Okay.
That's what's called overbalance, and it's crucial for well control.
So in this case, the pressure inside the well was too low to counteract the pressure from the surrounding rock formation.
Exact.
It's like the straw didn't have enough weight to keep the soda down.
Exactly. And that makes controlling the well, stopping it from blowing out, much trickier.
Wow.
The report details how they tried to regain control. First, they pumped in 50 barrels of brine, kind of a temporary solution, like putting your finger over the straw to stop the soda from fizzing over.
But obviously that wasn't enough. What else did they try?
They also relied on open valves at the wellhead as a secondary barrier.
Okay.
Imagine trying to screw the cap back on the soda bottle before it erupts, That's kind of the hope we're talking about here.
So not exactly a recipe for success, especially in this underpressured well. What did the investigation find about these control measures?
And here's where it gets even more concerning. The investigation found that common industry guidelines on well control might not have been sufficient for this type of, this underpressured reservoir.
What?
Those control measures that everyone assumed were enough, they might not have been enough at all.
So even if they had followed procedures to the letter, it might not have mattered.
Potentially.
Yeah.
And what's even more troubling is that the report found evidence of similar kicks or small blowouts at this very well over the years.
Really?
They weren't major incidents, but they were red flags, warnings that something wasn't quite right.
So you have to wonder, was this tragedy an accident waiting to happen? They were working with a system that wasn't designed for these specific circumstances, and there were warning signs that were potentially missed or ignored. So we talk about the well control issues, the pressure problems, the warning signs that were potentially missed, but ultimately this was a deadly explosion.
Yeah.
What does the report say about the cause of that?
Yeah, this is where the human cost of this tragedy becomes impossible to ignore. The report really highlights the abundance of potential ignition sources surrounding the wellhead.
Okay.
You've got the hot oil truck, various pieces of equipment, even something as small as the power pack for a torque wrench.
Things that could easily throw a spark in an environment flooded with oil and gas.
Yeah. Exactly. And while some ignition sources are unavoidable in this line of work, the investigation found that Chesapeake's contractors may not have adequately assessed the risk or controlled where these ignition sources were placed. In fact, their actions may have even violated industry recommendations.
So on top of the well control issues, there were potentially preventable safety oversights when it came to actually preventing a fire.
That's right. And there's one finding in the report that I think really highlights the power pack they were using near the wellhead. It wasn't intrinsically safe. That means it wasn't designed to prevent sparks in a flammable environment.
You would think that would be standard procedure in this kind of situation, to use equipment that won't set off an explosion.
You'd think so, right? And this detail points to a larger systemic issue highlighted in the report OSHA regulations. You see, onshore oil and gas operations are actually exempt from certain safety standards that other industries have to follow, like those concerning hazardous energy control and process safety management.
So even though the risks seem pretty obvious, the oil and gas industry isn't held to the same safety standards as other industries dealing with hazardous materials.
Unfortunately not. And the report mentions that, this isn't a new issue. There have been repeated recommendations to include onshore oil and gas under these stricter OSHA regulations, but so far nothing has changed.
So we have insufficient well-control guidelines, potential safety oversights, and a regulatory system that doesn't seem to fully address the risks involved in onshore oil and gas work. That's a pretty sobering picture. What can we take away from all of this?
On the surface, this is a story about a tragic accident, a routine operation gone wrong, but when you dig deeper, it reveals deeper systemic issues within the industry.
And it makes you think, if these changes could prevent even one similar tragedy in the future, wouldn't they be worth it? What are your thoughts on that?
Absolutely. This incident underscores the need for more robust well control plans, especially in underpressured reservoirs like this one. It highlights how crucial ignition source management is every single time. And it really calls into question the adequacy of existing OSHA regulations for onshore oil and gas operations.
This deep dive started with a single incident, but we've uncovered so much more. A web of complex factors that highlight the importance of safety regulations, industry practices, and a thorough understanding of the risks involved. Hopefully, by shedding light on these issues, we can contribute to a conversation about preventing future tragedies. Thanks for joining us on this deep dive. We'll have links to the full report and other resources on our website for those who want to learn more. Until next time, stay curious.